So in this video, we'll be going over empirical formula and molecular formula. So by definition, empirical formula is basically the simplest whole number ratio of the atoms in the compound. And let's look at some examples below, and this will be more clear for you. So the first option A, question A, we have BO 1.5. So as you can see, this is in 1.5 and the number has to be in whole number. So to convert this into a whole number, what we can do is that we can multiply this equation by 2. So this will give us B2O3, and now we can verify that this is the simplest form and the number of atoms are in whole number. So moving on, in B we have C6H6. This is in whole number, but it is not the simplest ratio. So we can divide this equation by 6 and we will get CH, that's it. So 1 and 1. It's not necessary to write the 1, but yeah. And in the next equation we have NaO 0.5, PO P.25 and O. So to convert the smallest number into whole number, we can multiply this equation by 4 to get all of them into whole numbers. So we will get Na2, P1 and O4. So this is the simplest whole number ratio. In the last D question, we have C3H2.67 and O1.33. So the first step that we can do is we can convert these decimals into fractions. It will help us to write them into more simpler form. So let's do that. So 2.67 is gonna be 2 and then 2 over 3. And if you want to convert this now into a fraction, we can do 2 times 3, which is 6, and then it's going to be 8 over 3. So it's going to be 8 over 3 for this one, and for O it is 1.33. So it's going to be 1 over 3, and then to convert this into a fraction again, it's going to be 1 times 3 plus 1, so 4 over 3. So O will be 4 over 3. And now we can multiply the entire formula by 3 to get rid of the fractions. So it's going to be multiplied by 3 and it will give you the answer of C9H8O4. And again we can verify that it is in the simplest whole number ratio. In the next example here, we have the mass of the compound given to us, and it is giving us 28.9 grams of carbon, 4.86 grams of hydrogen, and 38.57 grams of oxygen. So the first step that we can do is we can find the ratio of all these. So it's going to be actually we need to find the ratios of the moles, not the mass. So the first step that we have to do is convert these grams into moles, which the formula says that number of moles is equal to mass over molar mass. So for carbon it is going to be 28.90 over 14, and this will give us, sorry, the molar mass of carbon is 12, not 14. So it's going to be 2.41, and let's do the same for hydrogen now. So 4.86 divided by 1, which is the molar mass of hydrogen, is equal to, again, the same. And lastly, the hydrogen is going to be 38.57 divided by 16 from the periodic table, and this will give you 2.41. And now what we can do is we can write this in the ratio format. So let me just clear everything and write it. So this is the final ratio that we are getting, and we notice that the entire thing is divisible by 2.41. So if we divide it by 2.41, it's going to be 1 comma 2. It's going to be very close to 2, so we're going to round it up or down, and then last one's gonna be 1. So this is the final ratio and it is the empirical formula. And in part B now, they are asking us what is the molecular formula for the equation one given that the molar mass is 60.05 over here. So if we write this equation now, it's going to be C1 H2 and then O1. So right now the molar mass is going to be 12 plus 2 plus 16, which is equal to 30, and the molar mass that they have given in the question is 60. So the molecular formula is going to be times 2 of what we have right now. So in part B, the molecular formula is going to be C2H4 and O2. And if we calculate the molar mass of this equation, we will get 60. So another way of looking at the molecular formula is that we divide the molar mass given in the question, 60, divided by what the molar mass of the empirical formula, which is 30 over here, and we get 2. And we have to times the original empirical formula by 2 then, and that's it. So in the next question, we are given the percentage of the elements by the mass. So these are the ratios in out of 100. So we can just directly divide these by to convert it into the number of moles. So for carbon is going to be, and this will be 4.4425. Next is hydrogen, so it's going to be 11.18 divided by 1, which is the same. And for oxygen is going to be 35.51 divided by 16, which will give us 2.22. And now we need to convert these into whole numbers. So the way to do this is to divide all of these numbers by the smallest number that we have over here. The smallest number is 2.22. So divided by 2.22 divided by itself is gonna be 1. 11.18 divided by 2.22. Let's do it on the calculator. And we get 5, around 5. So we round it up or down. And 4.4425 divided by 2.22 is also gonna be 2. So this is the empirical formula. So if we write it now, it's gonna be C2H5 and O1. So this is the answer for A. And now in part B, they have given us the molar mass of the compound is 90 grams per mole, and they're asking us to calculate the molecular formula. So again, we just have to divide the molar mass given in the question divided by the molar mass that we have in the empirical formula. So if we do that, it's going to be 2 times 12 plus 5 plus 16, and that's going to be 90 divided by 45, and that's 2. So we have to times the empirical formula by 2. So in molecular formula is going to be C4H10O2, and this is the molecular formula.